theory. We have particulate nature of matter. We're looking at atoms, we're looking at ions, molecules, and compounds. Now, the first question to ask is, what does it mean by the particulate nature of matter? This simply means or explains that matter is made up of tiny, discrete particles which are constantly in motion and has the ability to combine with one another. Now, there are three basic concepts here. Number one, about this particulate nature of matter. Now, matter is made up of tiny, discrete particles. Number two is that they are constantly in motion, the particles. Number three is that they have the ability to combine together. So let's look at the word atom. The English word atom comes from the Greek word atomos. For you as a first timer in chemistry, you need to know that atom is simply the basic particle of an element. I take it again. Atom is simply the basic particle of an element. You can also say that atom is the smallest particle of an element. You can also say that atom is the indivisible. Notice the word small, basic, indivisible particle of an element. And this atom has a structure. I'm not that artistic. I'm going to draw. Alright, now this structure has a nucleus which contains two charges, a neutral charge and a positive charge. The positive charge is called protons. The neutral charge is called neutrons. Alright, neutrons. Now we have inside the nucleus is the proton and the neutron. Now we have electrons. My job. Electrons. This resolve around the orbit, and then this is the shell or the orbit. This is the structure of an atom. Alright, there's a typical structure of an atom. We need to analyze what is happening here. Now, we need to know that the nucleus of the atom contains the proton and then the neutrons, and then the orbit has the electron. Alright, now, but you need to know that the proton is positively charged and the neutron is neutrally charged. You can put that somewhere. The proton is positively charged, it's positive. The neutron is neutral. So we can see the word proton, positively charged, neutral, or zero charge. And then the electrons, they are negatively charged. Alright, so this is what we need to know about this structure. Now, we want to see a particle of an element, what it looks like. And a particle of an element, it will look like this. A particle of an atom or element will look like this. Let's use this as an illustration. We have the atomic number. We have the atomic mass. This is a typical example of a particle of an element. Now, if you are asked what is atomic number is the number of protons only in the nucleus of an atom. So this is protons only in the nucleus of an atom. Then atomic mass. This is the number of proton plus neutron in the nucleus of an atom? Well, if you are asked the question in the exam on which of these pairs is found in the nucleus of an atom, proton and electron, proton and neutron, neutron and electron, you can answer me. Let me take the question again. Which of these pairs is found in the nucleus of an atom, proton and electron, proton and neutron, neutron and electron? Of course, the answer is option B. It is proton and neutron. They are found in the nucleus of an atom. And then proton is positively charged, neutron is neutrally charged, electron is negatively charged. Now, you can be asked a question to find the number of proton, the number of neutron, a particle of an element. Let's say this element 11, 23, and then you are asked to find the number of proton, you are asked to find the number of electron, you are asked to find the number of neutron. Alright, now, what is proton? What is atomic number? Atomic number is the number of proton in the nucleus of an atom. Atomic number is the number of proton in the nucleus of an atom. So open your eyes. Where is the atomic number? 11. So 11 proton is 11. You know why proton is 11? Because atomic number is the number of proton only in the nucleus of an atom. Think of that. This is a number of protons only in the nucleus of an atom. That's atomic number. Then electrons. For electrons, you need to know that electrons depend on whether the atom of element is positively charged, is negatively charged, or is neutrally charged. If you look at this, when we get to ions, we'll discuss that. If you look at this element, there is no charge. There it is a zero charge, no charge. So definitely there is no oxidation or reduction. There is no reaction occurring in this element. And definitely the electron will be 11. Meanwhile, the number of neutrons is atomic mass is equals to proton plus neutron. If the atomic mass of this element is 23, alright, the number of proton is 11, number of neutron, we don't know that, so we put x. Then 23 minus 11 is equals to x. Definitely 23 minus 11, that should give me 12. So 23 minus 11 is 12. That is the number of neutrons. So this should be 12. Okay, now let's go to ions. What are ions? Ions are a group of atoms of elements that are chemically charged. I take it again. In the most simplest term, ions are a group of atoms of elements that are chemically charged. And there are only two types of ions that we have. We have the positively charged ions, known as the cations. Ions, cations, and anions. Okay? Now the cations are positively charged, the anions are negatively charged. Meanwhile, the example of cations, calcium, aluminium, potassium, sodium. Example of anions, you can have fluorine, and sulfur. These guys are known as anions. Meanwhile, there are some elements that are neutrally charged, as I've told you, no charge. The neutral elements. The neutral elements are the helium, the neon, and the argon. Now, the reason why this is neutrally charged is because of the octet configuration. There is no atom share electron in order to combine with other elements because they have octet configuration. If you want to understand what we mean by octet configuration, duet configuration, we have a video where we discuss chemical bonding. But the prerogative of today's class is to give you the concept you need to know as a first timer in chemistry. And then we don't want to bore you with so much information. We want to take it step by step. And if you're interested in knowing why this is octet configuration or duet configuration, or why these chemical elements combine together, you need to visit our video on chemical bonding, where we discuss about electrovalent bonding, pure covalent bonding, coordinate covalent bonding, metallic bonding, hydrogen bonding, and every other bonding that is therein. And then we want to go to the calculational aspect of this, and then we want to do something with it. Let's say you have an element, and then this element is atomic number 11, and then mass number 23, and it has a positive charge. I have another element, it has atomic number 16, mass number 32, and it has a -2 charge. Now, I told you that ions are a group of atoms of elements that are chemically charged. Notice that the charge here is +1, the charge here is -2. Now, to find the number of protons, here, let's use P because of time. Number of protons. Now, let me use electron before neutron. Electron, electron, and then neutron, and then neutron. To find the number of proton here. Proton, what is atomic number? The number of proton only in the nucleus of an atom. Definitely, proton is 11 over here. Proton is 16 over here. Now, the electrons. The electron over here is losing a charge because this electron is actually sodium, because sodium is atomic number 11. Now, sodium has atomic number 11, which means that the configuration will be 2, 8, and 1. Now, if this sodium becomes positively charged, it will lose an electron. The configuration becomes 2 and 8. Now, this one is lost. What is happening here is that electron is being lost, and that is oxidation. Now, this is chlorine, which means that this will be 11 minus 1. Definitely, the electron will be 10. Why? Because it's losing 1 electron. Now, let's see over here. We'll apply the same thing, but let me draw what it means. Chlorine receives the electron and becomes negatively charged. Now, what is happening is that chlorine has atomic number 17, which is 2, is to 8, is to 7. And it receives an electron and becomes 2 is to 8, is to 8. So the electron will become, sorry, this is not chlorine, this is sulfur. All right? This is sulfur, not chlorine. There's a mistake there. All right, this is sulfur. Let's take it again. If it is sulfur, it means that sulfur will receive 2 electrons. And when it receives 2 electrons, it will change because it needs 2 electrons to become stable. If it is 16, the outermost shell will be 2, is to 8, is to 6. Now, 6 remains 2 to become 8. Then it will now become S minus 2. After it has received this, so the configuration is 2, is to 8, is to 8. So that's what is happening here. So the answer here is 16 plus 2, and it is definitely 16, 17, 18. 18. Now let's go for the neutron. The neutron is, let me make a space for myself. I'll need a space. Let's make a space here. For the first one, the neutron is atomic mass is equals to neutron plus proton. The atomic mass of the first one is 23, and then the neutron, we don't know that. Proton is 11, and then we have 23. Move 11 to this side is equals to x, and x is equals to 12. The neutron number is 12. We have solved that before. And then we have the second one. The atomic mass is equals to neutron plus proton. Atomic mass over there is 32, and neutron, we don't know that. Proton is 16. Moving 16 to that side, 32 minus 16 is equals to x. 32 minus 16 is 16, so x is equals to 16. So number of proton here is 16. So this is how to solve for number of proton, number of electron in a particular particle of an element. So having said that, we want to explain what it means by molecules. What does it mean by the word molecule? Well, molecule is the combination of two or more atoms. So we have atom, two or more atoms combined to form molecules. And then we have substance. Okay? Now, I would say that we have, if the molecules contain more than 2 atoms or 3 atoms, that process can be determined by the atomicity of the molecule. It can be monoatomic, it can be diatomic, it can be polyatomic. If it is monoatomic, it has only 1 atom. Example is helium, mu, and if it is diatomic, it means it has 2 atoms of elements. Example is hydrogen molecule, chlorine molecule, oxygen molecule, and nitrogen molecule. If it is polyatomic, it has more than 3 atoms of elements. This can be tetrasulfur, phosphorus, that is white phosphorus, and we have octosulfur and ozone. So now, these are examples of polyatomic molecules. Meanwhile, how molecules are formed? I told you that we have a video on chemical combination where we discuss how molecules are formed. But let me just give you just one molecule. Let's pick one molecule and then we will show you what is happening there. Let's pick chlorine. Let's pick chlorine. Let's work on it. And then we'll give you the combination. Chlorine, where is that? Chlorine, which is diatomic. So the chlorine, now we want to work on it. Chlorine has atomic number 17. So the root structure of chlorine will be 7 electrons out in their atom share, 6. 7. You see that? 1, 2, 3, 4, 5, 6, 7. Just as I said, 2 is to 8 is to 7. What I did before. Alright, so it's going to combine with another chlorine, which is also 7. And then electrons will be shared. And this sharing of electrons is known as pure covalent bonding. So what will happen there is that we have electrons to be shared between this chlorine. And then the configuration will look like this. Notice that this is 2, 4, 6, 8. 8 octets. This is 2, 4, 4, 6, 8 octets. Now, it is not in each, both of them are in their octet configuration. So they gain a kind of stability. Now, why atoms of elements combine is that they want to be stable. Now, we go to compound, ionic compound. Let me turn on the top. Ionic compound. What we mean by the word ionic compound. Now, what that means is that there are combinations from a positively charged atom and a negatively charged atom. Now, when these react, they are going to form sodium fluoride. Now, let me tell you what is involved in a reaction. Now, sodium gives out an electron and becomes positively charged. Normally, sodium is atomic number 11. 1, it gives out an electron, becomes an octet configuration, having a positive charge. This is called oxidation. And then fluorine receives the electron, and then this is fluorine has atomic number 9. So we have 2. 2 minus 9, that should be 7. 7, and then we have fluorine, which is 2, is to 8. You see that now? So this is what is happening here. And then as a chemistry student, you should know your number 1 to 30 elements. Okay? You should know your number 1 to 30 elements. We have a video of that too, where we show you the acronym to use to remember these elements. Alright? So that is on it on ionic compound. Meanwhile, this is all we've got for you in this video. In our subsequent series, we are still on the first timers chemistry or chemistry for beginners. and you don't want to miss the next video. I'll be waiting for you right there in the class. Thank you very much for watching. Thank you very much for your time. Bye.